This is lesson 7.4 about the quadratic formula for algebra 2. So there's a couple terms to define. One of them is discriminant. So before we get to the discriminant, I want to skip forward one page. So if you guys can flip, or I think you can just look further down in your notes, I want us to fill in the quadratic formula first. So the quadratic formula helps us find solutions to quadratics. So the purpose of this is to help us find the places that a graph or a parabola crosses the y-axis. So this functions to help us find these two locations, or the two x values. The formula for it is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And you have to be really careful to make sure that you include this negative b above the line, because a lot of students will neglect to do that and it totally messes it up. There's two solutions in here, and those two solutions occur because of this piece right there. So if I break this and write it into two separate equations, you'll see the two possibilities. Mathematicians are just pretty lazy. That's why they put it all together in one. So one of your solutions is x equals negative b plus the square root of b squared minus 4ac all over 2a. The other is x is equal to negative b minus the square root of b squared minus 4ac all over 2a. So again, the difference between these two solutions is we have a plus in one and we have minus in the other. So moving backwards to discriminant and roots, or zeros, or x-intercepts and solutions. Discriminant is the part of our quadratic formula that said b squared minus 4ac. That is the discriminant. It's the part that's under the square root, or the radical as it might be referred to. So the purpose of the discriminant is to tell us how many potential solutions there are. So if the discriminant equals, let's say, a positive number, we're going to end up with two solutions. And that's because we will have plus some amount and we will have minus some amount. The next option is if it equals 0, there is one solution. And that's because if we come back here and this piece is 0, it just disappears. So we would end up with negative b over 2a in both instances. So we'd end up with the same solution twice. And then the last possibility is if it equals a negative, and we would have no real solutions. Or another name for it is imaginary, and we'll start that in the next section. We'll talk about that. So if it's positive, there's two solutions. If it's a 0, there's one solution. If it's negative, there's no real solutions. If you type in your calculator the square root of a negative, it will say non-real answer. You just can't take the square root of a negative. And then roots, zeros, x-intercepts, solutions. This is what I drew on the previous page. It's these two values. It's the value of x when the parabola crosses the x-axis. There's a lot of different names. There's roots, zeros, x-intercept, solutions, but it all means the same thing. It means where does it cross the x-axis. All right, so let's look at a couple uses of this. The quadratic formula is nice because in the previous sections we'd had about 4 different methods to factor an equation or polynomial. But the problem is it's really complicated and hard to keep straight which one you should use. The quadratic formula will always work. This is like my go-to tool. If I can't factor it really easily immediately, I just go straight to the quadratic formula and I don't waste any time trying to dilly-dally with the other stuff. So just go to the quadratic formula. So here we got x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. If you come see me in class, I'll sing you like Pop Goes the Weasel, but I'm not going to sing it on YouTube. So to use this formula, the first thing we have to do is figure out what A, B, and C are. So A, let me scroll up a little bit. These are the A, B, and C that I'm referring to. So for this first example, A equals 1 because there's a coefficient of 1, B is -4, and C is -12. So what we do is we fill in our formula. X is equal to opposite of -4 is +4, plus or minus the square root of B squared minus 4AC, all under the radical, and then all over 2A. To simplify this a little bit, we'll go X is equal to 4 plus or minus the square root of 4 squared is 16. And then -4 times 1 is -4. -4 times -12 is +48. So we have 16 plus 48 is 64, all over 2. And I'm going to break this into our two solutions. We've got X is equal to 4 plus 8 divided by 2. And X is equal to 4 minus 8 divided by 2. This became 64, which then became 8, just to be really clear about that. So we end up with X is equal to 12 over 2, which is 6, or X is equal to -4 over 2, which is -2. Now, what you might have noticed is you could have factored this pretty quick. -6 times 2 is -12, and then they add up to -4. So you could have factored if you wanted to, but the quadratic formula will work. Just the other method might be faster. Okay, we'll try to do one more. Hopefully I don't get cut off, and then I'll stop it and we'll start a new video. So here we've got A, B, C. X is equal to -b plus or minus the square root b squared minus 4ac all over 2a. So -8 squared is 64. -4 times 16 is 40, 64. So it's 64 minus 64, which is 0 over 2. Well, this square root of 0 becomes, just disappears. That's just going to go away. So we end up with one solution because the discriminant is 0. We get 8 over 2, so X is 4. If you had factored it, you would realize that -4 times -4 is 16, and added together they're -8. So these would be your two, this would be like a double root. So if you can recognize this factoring, that'll work too. So I'll pause the video and I'll start a new one for the next part.